Alright, so we're going to be talking about section 1.2, which will be the applications of the linear equations. In section 1.1, we talked all about how to solve linear equations, and now we're going to see some of the reading problems, you might call them, or the applications of the linears. So we're going to look at some applied problems. Specifically, we're going to look at some geometry problems and some mixture problems, and then we're going to talk about modeling, what modeling is in algebra. So steps to solve any applied problem. This is in general the steps that one should think through. Step one, which seems kind of like, well, obviously you should read the problem, but it really is the most often missed step or skip step, because a lot of times you look at a reading problem and you're like, oh shoot, I just should automatically know how to do that. But you need to read it, reread it, until you carefully and completely understand it. You might want to draw some pictures. That helps me a lot, so I always say that. I don't know if that helps everyone. I think it does a lot, though. Try to draw a picture, note any important details in the problem, label it if you can, and whatever else helps you to wrap your mind around the question. So that's the first big step, is try to give yourself a chance to let it soak in, which could require multiple readings of the problem, and then try to draw upon, like, have I seen this problem before? Is there a pattern I've seen in a previous class? Or you know, that's definitely helpful if you have a pattern, you've seen a way to attack it. But sometimes it's good to see it fresh and just think, how would I actually think about this problem? All right, so that's step one. Step two, then, you want to try to assign the variable x to the basic unknown. When you read the problem, sometimes they refer back to this basic unknown. They'll build on some basic value. So try to listen to the reading and hear where the x seems to be assigned. Now you can assign x to even the number that's built on, but it'll make it a little harder to interpret. So there's more than one way to solve all reading problems, of course, but I find it easiest if you can let x be the most basic in the reading. Then express the other unknowns in terms of that variable if possible. Step three. Then the big thing, if you can get that equation on the paper, that's always the big victory, right? Try to create an equation from the information given. Then, of course, you're going to solve that equation. State the answer, which I know you're like, of course, but sometimes we also forget to think about, does the answer we've got for x completely answer the question asked? Sometimes there's a follow-up. You're supposed to double that answer, or you're supposed to go back into the formula, interpret the answer. So make sure you've answered the final question and it seems reasonable, and then you can check it back through the problem. Okay, that's your pep talk about how to tackle a reading problem. So I like to start with this example from my life. I always feel like I need to tell this. It's an ode to my sister. I have this sister who's 23 years older than me. They're just super close, a mother sister to me that I love so much. So I always feel like I've got to mention her in here. And this is so true. This is an actual experience that I had. And I remember my sister is 23 years older than me. On my 23rd birthday, I distinctly remember she called me and we were talking, and of course she would have been 46 when I was 23, and she asked if she would ever exactly double my age again. And at that time, when I was 23, I was actually through my master's degree, or I was close. I was definitely through my bachelor's degree in math. I had a bachelor's degree in math, so I should know something about math. And I remember thinking, I don't know, and not having the patience to really think about it. But anyway, at some time, I was teaching this algebra lesson, because I would have been teaching algebra at that time at 23. I was teaching, I believe, at East Carter Middle School, and I thought, well, my goodness, that's really not that hard of a question. It's what I teach, and I should have thought about that. So I, at the time, being 23, had no idea, just to being honest. Even though I had a degree in math and was teaching algebra, I had not learned to use my craft for real life. It can be hard to connect algebra at times. I know that's true. And I always enjoyed just the algebra patterns. I was satisfied with algebra. But one day during an algebra lesson, it hit me that I needed to practice what I preach and use the steps to answer a question like this. So it's really not that bad when you think about it. if you let the basic unknown of the situation, which would be our ages at any point in time, because she's asking me, will she ever double my age again? So we're saying in general, at any point in time, when my age is X, I let me be the X, and then I built on that and call my sister, at any point in time, she's X plus 23. So we express our variables, and then the question is, when will my sister's age be double my age? Can I make that into an equation? And why, sure I can. My sister's age, which is always X plus 23, equal to double my age. When does my sister's age, X plus 23, equal exactly 2 times, my age is X, so 2 times X. So that's not a bad linear equation. And very solvable. All I need to do is throw this X across the line, making it a minus X. So 2X minus X is 1X. So you get X equals 23. So that solves to be one and only answer to this. There's one and only one, I should have said, answer to this question. Since it's a conditional linear equation, like we learned in the last section, when you solve a linear equation, you're only looking for one answer, unless it's one of those special cases that's where the variables drop out and you have either always true or a never true. But if it solves and you get X equals, that means it's the one and only answer. We can be assured that this is the one, oh, there I said it correctly, one and only one answer of X equals 23. So that was a very special event, the time that my sister's age was double mine. Now you might ask other questions, is will she triple my age? Will we equal each other's age? That leads us to what we learned in the last section, kind of the nonsensical equation. Will my age ever equal my sister's age? In real terms, algebraically, that would mean the X's brought across the line, the X's drop out, and we have a contradiction. No, it should not happen, right? She's 23 years older than me. Okay, so no solution to that, or other things we could ask. All right, now let's get to some of the other business here, some different types of reading problems that you might see as you go through your homework. A lot of times there's these typical problems that the book likes, I guess, typical reading problems that you may see in your book, and these are the kinds you may see on your test, so I definitely want to hit those. So the first thing we'll talk about is sort of what I just did there, just basic unknown, just sort of like a brain teaser question where they ask you what seems like is maybe silly questions sometimes, but there are also warm-ups to help us learn how to set up equations and let X equal a variable. All right, so here we go. The first one, and feel free to always pause the video and think about it before you jump back in. That's the magic of video, right? But I'll read this to you. The instructions for a woodworking project require 3 pieces of wood. The longest piece must be twice the middle-sized piece, and the shortest piece must be 10 inches shorter than the middle-sized piece. Do you notice how they kind of refer to that middle-sized piece a couple of times? It seems like it's the basic thing, if you read that, the basic unknown, something to build on. So Tommy has a board that's 70 inches long, and he wishes to use. How long should each piece be? So you might want to draw this picture out. And notice he's not just going to chop it into equal parts. That'd be too easy, right? 70 divided by 3. He's chopping it into some sort of small, medium, and large piece. And I don't know exactly, but it kind of helps my brain get around it. The middle-sized piece we're going to call X. And you might even write the words, let X equal the middle size. And then he builds on that. The longest piece is twice that. So 2X is this longest piece, and then the shortest piece is 10 inches shorter than the middle. So I don't know if I left room to squeeze that in there, but it'd be X minus 10. So X minus 10 is how I could express the shortest piece of wood. And then these 3 parts added together adds up to the total distance of this piece of wood, 70 inches. All right, so the equation would then be, just in any order really that you feel like, so I think I'll write that up here, X minus 10 plus X plus 2X. The 3 pieces added together equals 70. And then this is now in the form that we used in the last section to solve. We combine any like terms on the left side. This is a 1x and a 1x and a 2x. Those will add to make 4 x's. And then we have a minus 10 equals 70. Bring the minus 10 over, making it plus 10. 4x equals 80. Divide by 4 on both sides. X equals 20. So now that you know x, the middle piece is 20, make sure you answer all the questions that are asked. It might ask you about the longest piece or the shortest piece or just the middle sized piece, and then you'd be done, right? But it says how long should each piece be, so you do need to answer fully. So the middle sized piece is 20, and these are in inches, right? The longest piece is twice that, so twice 20, which is 40 inches. And then the shortest piece should be our 20 we found for x, 20 minus 10, or 10. And then to check, does that make sense? Does that seem reasonable? If I would have had like 100 for an answer, or missed a decimal and had 200, and it's only a 70-inch piece of wood, and you kind of know, you've wrapped your head around it right there, you'd know, oh, 200, that seems pretty big for this out of range. So that looking back at the problem really is a good idea that we oftentimes skip, and I'm bad for that too. I get in a hurry. So notice that works. That is 70. It meets all the parameters of the question. And that's really the lesson. I could stop right there, and you might wish I would, but that's kind of the lesson is read these problems carefully, follow the recipe of letting x be something, write an equation, solve the equation, interpret the equation. So that is it, but I'm going to continue on to give you some examples to follow, but that would be the concept. The overall, that's what you need to know. Okay, but I'm going to move on. Number 2. Again, just a nonsensical, no reason really to do this, but to just get us in the habit of this process. If 2 is subtracted from a number, notice that a number is not specified. That's going to be our variable. And this difference is tripled. The result is, and that's usually where we find the equal sign in the verb. The result is, or equals, 4 more than the number. This unknown number, we're going to call it x, and find the number. So I would let x equal the number, the unknown basically here, no real detail to it. And this is kind of tricky if you haven't done this in a while or heard this, but when it says 2 is subtracted from, that means the 2 needs to be behind the x, right? It's coming from the number, so the number needs to be in front, and then subtract the 2. And this difference, so it means parenthesis that, find that difference first, you might infer. Find this difference and then triple it. So parentheses were inferred in that. I don't know if you can kind of hear it, but if you think about it, it wants you to find that difference. So that means do this first, subtract it first. So parentheses mean do this first, and then triple that answer. So that would be distributive property. Then the result is, there's your equal sign, 4 more than, which is plus sign, the number. And that gives us an equation that's now solvable. We can distribute and solve this equation. All right, 3x minus 6 equals 4 plus x. Bring your x across the line. 3x minus x is 2x. Take the minus 6 to the other side. That's 10. Divide by 2. X is 5. The number, the magical number. All right. You know, I might let the video pause right here and come back in for the next section, distance, because I try to keep my videos down to 15 minutes each to give you a little break. So I'll check back in with you in a little bit.